Number 45. How long must a flute be in order to have a fundamental frequency of 262 hertz? On a day when air temperature is 20 degrees Celsius. It is open at both ends. All right, so check out number 42. I went through a brief overview of the concepts, that are basically in this problem. So we're going to run through it. So tube is open at both ends. So that means we're going to be using the formula that the frequency of the nth harmonic will be equal to the nth harmonic multiplied by the velocity of sound divided by then 2 times the length of the tube. And the harmonics here can be the first harmonic, the second harmonic, the third harmonic, etc. So we know and remember that the fundamental frequency corresponds with the first harmonic. All right. So essentially this formula kind of reduces down if you want to think about it. If I'm dealing with the fundamental frequency, then I would plug 1 in for n, and this thing just becomes then the velocity of sound divided by 2 times the length of the tube. Okay. Now they told us the fundamental frequency, right? 262 hertz. So I know this piece. They're asking me to solve for the length of the tube, and therefore I got to know the velocity of sound, right? At the current conditions. Did they tell me the sound, the velocity? No. But what did they tell me? They told me the air temperature. Now you got to start thinking, how is air temperature related to sound speed? Oh, right. This formula, right? 331 times the square root of t over 273. So what I can do now is do that substitution, right? I can say that the fundamental frequency will be equal to now 331 multiplied by the square root of the temperature in Kelvin divided by 273, and this whole thing is then divided by 2 times L. Now I want to solve this thing for L, so why don't we just do a little cross multiplication. You can literally take the L out of the denominator on the right, bring it up into the numerator on the left, bring this fundamental frequency from the basically numerator on the left and down into the denominator on the right, and voila. There's the formula. Simple. Now what do we have to do? Just plug it all in, right? So 331 times the square root of the Kelvin temperature, so that's going to be 273 plus the 20 degrees, divided by then 273. You can also memorize, this is a common value, but it's probably better to know it from the formula. So this is going to be 2 multiplied by that fundamental frequency of 262 hertz. All the units are right. So let's just do the calculation. All right, so 331 multiplied by square root of now 293 divided by 273. Get that value and then divide it now by 2 times 262. So the length of the tube here, L, is going to be 0.654 meters. And there you go. That's it. All right, guys. So thanks for tuning in. Appreciate it. Hope this helps. If it did, help us out. Hit that subscribe button. Tell your friends. We appreciate it. Take care.